This is Photographing the West podcast, the podcast for people who love to explore the western highways and byways while photographing the landscape and wildlife. And now here's your host, Kirby Flanagan.
Hello, and welcome to the Photographing the West podcast, brought to you by Flanagan Photos. I'm your host, Kirby Flanagan. This is episode number 44. With me today is author, ornithologist, field researcher, and project manager Scott Weidensaul. Welcome to Photographing the West, Scott. Scott has expertise on many subjects in the natural world, but today we're going to focus on his work in migration. Most people, aside from birders, have a simple concept of migration. Birds fly south in the winter and north in the spring. Your book, Living on the Wind, makes it clear that migration is much more complex than that. Could you discuss that, please?
Yeah, so most people have a concept of bird migration as this very linear north-south event. Birds go south in the winter and they come back north in the spring. But the fact of the matter is birds are ping-ponging around this planet, like pinballs in a pinball machine. A place like Denali National Park in Alaska, where I'm working with the National Park Service to study bird migration, the birds that breed in central Alaska literally fan out over 3/4 of the Earth's surface every year. We've got birds that are migrating to southern or central South America, to northern South America, to the Caribbean, to the southeastern United States, to Mexico and Central America, to the American Southwest. You've got birds like Arctic warblers that are migrating into Asia, going to places like the Philippines and Borneo. Birds like the northern wheatear, which is this beautiful little black and white thrush-like bird that migrates to East Africa. And you've got seabirds like long-tailed Jaegers that nest in the high tundra in the park, but then spend the winter out somewhere in the Pacific Ocean. We don't really know where. Just this summer, for the first time, we, along with the Smithsonian Migratory Bird Center, were able to put satellite transmitters on long-tailed Jaegers nesting in Denali National Park. And those birds are already moving out of the park and moving out into the Pacific. We have no idea where they're going to go. There's some indication that those birds may migrate as far south as the waters off New Zealand. And we're going to find out. So, yeah, these birds are moving back and forth constantly, and it seems bizarre. Why would a tiny little bird that weighs less than half an ounce migrate thousands and thousands of miles? It seems dangerous. It seems like it must be exhausting. There's got to be closer places where that bird can spend the winter. But migration is driven primarily by food, not so much by weather or temperature. And by moving these tremendous distances, these birds are able to take advantage of seasonally available food supplies in different parts of the world. So, if you're a small insect-eating bird in the boreal forests of, say, British Columbia or Alberta, there's lots of insects there in the summertime. Not so many in the winter. So it makes it worth your while to migrate all the way down into Central America for that off season when you don't have to breed, where there's an abundance of not just insects but also nectar and fruit, because a lot of these birds shift their diet in the wintertime. So by moving across thousands or even tens of thousands of miles each year, they can get the best of all worlds at all times of the year. The best possible place to breed and raise their young, the best possible place for them to spend the winter. So there's a method to their madness.
Your book on migration, Living on the Wind, is now nearly 20 years old. How has our knowledge of migration changed over that period of time?
We've learned an incredible amount about both the physiology of migratory birds, how they're able to physically do what they do, and also how they're able to navigate and orient. Because it's kind of like there's two separate pieces to the puzzle here. I mean, physiologically, how are these birds able to fly these incredible distances they fly, and how do they find their way along the way? As far as the physiological piece goes, there's also potentially some really tremendous applications for humans. I mean, for example, who among us would not like to be able to get in prime physical shape, ripped and buff and muscular and toned without actually having to exercise? Migratory birds can do that. We don't really know how, but even if you prevent them from exercising, as they come into migratory condition, as the length of the day changes, as the hormones in their bodies change, their muscle mass in their breast muscle increases, their muscle mass in their heart increases. With some birds, like there's a bird that breeds in western Alaska called the bar-tailed godwit, which migrates 7,200 miles nonstop across the widest part of the Pacific Ocean every year to New Zealand and Australia. So this is a flight of 7 to 9 days of continual nonstop flight. Before the birds take off on this trip, they feed voraciously. They lay on tremendous amounts of fat. They more than double their weight. When they no longer need their digestive organs, having gained as much weight as they possibly can, their stomach and their liver and their kidneys and their intestines shrink dramatically, while at the same time their muscle mass and their chest muscle, their breast muscles, and their heart mass increases dramatically. Some birds, their brains actually increase in size before they migrate. While they're migrating, they can actually cannibalize their internal organs. After they've used up all their fat reserves, they can start cannibalizing the tissue in their internal organs. So it's basically like, arriving on fumes, and then regain their weight, regrow their organs, bounce back within a matter of days or weeks without any long-term physical damage. If you or I did that, if we went through these periods of tremendous obesity and then, extreme anorexia and then tremendous obesity, it would kill us. I mean, that's terribly damaging to our hearts. That doesn't happen to migratory birds. Somehow they're protected from that, and scientists are trying to figure out how and whether that's applicable to people. Migratory birds don't suffer from sleep deprivation. In fact, some of them are actually able to put half their brain to sleep for a couple of seconds at a time, alternating back and forth between the different hemispheres of their brain while they're migrating. So, I mean, there's so much that migratory birds are able to do that we wish we were able to understand, because it might have serious health and wellness applications for humans. We're also learning a lot about how these birds are able to comprehend the world and how they're able to navigate and orient themselves. One of the most dramatic discoveries in recent years has been how birds are able to orient magnetically. We've known for decades, for more than a century really, that birds have a magnetic sense, that they can sense true north. They can sense magnetic north. We always assumed it was because they had little bits of magnetic crystal in their brains that functioned like a compass. Well, it turns out what we thought were magnetic crystals in their brain are actually not. They're actually part of the bird's immune system. But what the birds are using is an aspect of quantum physics known as quantum entanglement, which is such a bizarre element of quantum physics that even Albert Einstein described it as spooky. This is the same aspect of quantum physics that scientists think may eventually allow us to do like Star Trek-style teleportation. In a nutshell, what birds are able to do using quantum entanglement in their eye, they have pigment molecules in their eye, and the quantum entanglement allows them, through this pigment in their eye, to see the Earth's magnetic field as they're flying through it. We think the northern lights, the aurora borealis, is a beautiful and spectacular phenomenon. This must be like the aurora borealis on steroids. And every migratory bird, so far as we can tell, is able to see that. You know what I would give to be able to see the Earth's magnetic field like that? We're just barely starting to scratch the surface of understanding what migratory birds are capable of doing.
You were pretty pessimistic about the outlook for migratory birds when you wrote your book. Has that view changed any since then?
Right. And, I think the fact of the matter is there's a lot of bad news out there for migratory birds. I mean, I can't sugarcoat that. We've seen the populations of many species of birds, especially migratory songbirds, declining over the years. We've got archived weather radar images all the way back to the 1950s that show that these huge flocks of migratory birds that cross the Gulf of Mexico, for example, every spring, have declined by as much as 50 to 75% in the last 50 years. But while the populations have declined, I mean, there are still hundreds of millions of migratory birds out there. And in fact, there are so many migratory birds that anybody with a computer can watch them in their migration on their computer at night. So this fall, in September or October, late August, at the peak of the migration, after dark, go on to a Doppler radar weather station. The National Weather Service has lots of them. Go on your local Doppler weather radar site and click on clear air reflectivity, which is the setting you want. And even though it may not be raining outside, you'll see this huge blossom of blue and green on the radar scope. That's hundreds of thousands to millions of migratory birds in the night sky overhead migrating. Most birds migrate after dark, and so their migrations are hidden from us. We can't see them, but radar is another new technology that's opening up that world of migratory birds to us. So even though populations are down, even though the trends are not good, we still have tens of millions of them out there, and there's still time for us to do the things that we need to do to protect and preserve them, and particularly protecting the habitat that these birds need. Not just where they breed, not just where they spend the winter, but the stopover points along the way that these birds need in order to rest and refuel, recharge their batteries. And it doesn't have to be a huge national forest or a huge national park or national wildlife refuge. Your backyard, if it's got a nice little thicket near a corner, a couple of native berry-producing shrubs, can be a good stopover site for a couple of birds on their migration. You multiply that across all the backyards in the United States, and that's a lot of habitat for migratory birds. We're getting more sophisticated about how we approach the question of protecting migratory birds and preserving them for the future. And one of the things that scientists are realizing is that we can do this in a very diffuse way, that every little patch of ground, every little thicket, every little backyard nook and cranny can make a difference for a couple of migratory birds. And you scale that up across a landscape, and it makes a difference for millions of migratory birds.
Climate change is a major concern today. There's some evidence that birds and mammals have begun to adapt to the changes in temperature and seasons. Is this a reason for hope?
It really depends on the bird. Where I live here in eastern Pennsylvania, we've got species like red-winged blackbirds, eastern phoebes, eastern bluebirds, turkey vultures. These are migratory birds that are on average are coming back weeks earlier in the spring than they did 40 or 50 years ago. They're leaving on average weeks later in the fall than they did 40 or 50 years ago. But these are all species that winter within the United States, mostly within the southeastern United States. They can tell whether we're having a warm early spring here in the east or a cold late winter, and they can either advance or delay their migration based on that. The birds that winter in places like the Caribbean or Central America or South America, which is where the vast majority of our migratory birds winter, they have no way of knowing whether it's an early spring or a late winter. A Blackburnian warbler in the foothills of the Andes has no idea what the weather is like in Michigan or Pennsylvania. And those birds are coming back on average to the day when they did 100 years ago. Their schedule is set not by the weather, but by their internal circadian rhythm, their internal clock, and also the changing ratio of daylight and darkness known as the photoperiod, as the days get shorter, as the days get longer. And that hasn't changed. So what's happening increasingly is many of these migratory birds, especially those that migrate long distances, are finding themselves farther and farther and farther out of sync with the climate and with their environment. they're basically arriving too late in the spring, after the leaves have already emerged, after the insects have already emerged. Their migration is timed, like for example with forest nesting songbirds, their migration is timed so that they get back in time to set up a territory and find a mate and build a nest and lay their eggs and have those eggs hatch just when the insect population reaches its peak, because especially the caterpillar population, most small birds are feeding their chicks caterpillars. And what we've seen in some parts of the world, especially in Europe, is that some of these birds have gotten so far out of sync with that seasonal abundance of insects that they're no longer able to raise their chicks successfully. There's a bird in Europe called the pied flycatcher. Beautiful little black and white bird. It winters in sub-Saharan Africa, migrates across the Sahara and the Mediterranean, and goes back to Central and Western Europe. And they've gotten so far out of sync with the seasons in Europe that their population has collapsed by like 90 or 95% in the last 15 or 20 years. Now, there are some species that just by dumb luck, have been able to keep up with the changes in the climate and the changes in the seasons. We talked before about bar-tailed godwits migrating across the Pacific Ocean. There's another type of godwit called the Hudsonian godwit that winters on the coast of Chile and breeds in south central Alaska. And as the climate has been warming in Alaska, it's been warming at the same rate all along that bird's migration route up the coast of South America and up through the Pacific and into Alaska. And so they've been able to keep pace easily. But there's another population of Hudsonian godwits that winters in Argentina and breeds in Hudson Bay in central Canada. And they found themselves between a rock and a hard place with climate change, because, climate change doesn't always mean things get universally warmer. What's happening in central Canada is that the month of May has actually gotten colder and snowier than it has traditionally. And so these birds migrating north, they run into this bad weather, they run into this late lingering snow and ice that holds them up and delays them. And then they finally get up to the breeding grounds in places like Churchill on the coast of Hudson Bay. And then June and July come along, and June and July in central Canada are now dramatically warmer than they used to be. So you have May is dramatically colder than it traditionally was. June and July are dramatically warmer. What that means is the seasons are completely screwed up for these birds. By the time their chicks hatch, the seasonal explosion of insects that the chicks depend on has already passed. And most years, these birds are not able to produce any surviving chicks at all. That central Canadian population is probably doomed. And we're seeing that increasingly with migratory birds, especially long-distance migrants, these birds that are traveling thousands of miles a year, because their migrations and their breeding are so precisely timed and so dependent on arriving at just the right place at just the right time when there's an abundance of food. And as climate change messes up the timing of that system or messes up the abundance on which they depend, they're just not able to adapt. I mean, it's the change is happening so rapidly that these birds just have not been able to evolve to keep up.
So not a lot of good news, it sounds like.
No, I'm afraid I don't have a whole lot of good news today. It certainly seems that way. I mean, I think any of us who work with migratory birds are really aware of the fact that it can sound like gloom and doom, but there's an awful lot that we can do in our day-to-day lives that can make the world a better place for migratory birds. And I'm not talking about like moving into the woods and living in a bark shack and eating twigs. I mean, it's just simple things like planting native plants in your backyard rather than exotics from around the world. I mean, if you plant, like for example in the fall, if you've got just a couple of berry-producing native shrubs like native dogwoods, native viburnums, spicebush here in the east, these are like some of the native hollies. These are high quality food sources for migratory birds like thrushes and tanagers and catbirds and a lot of other species, grosbeaks. They can feed on the berries in those plants in your backyard during a quick little stopover that they're making on their way to Central or South America. Not using dangerous pesticides in your backyard. And if you're planting native plants, you don't have to. If you have a cat, keeping your cat indoors, because cats kill more birds than any other human-related cause of mortality. They kill more birds than cars, they kill more birds than wind turbines, they kill more birds even than windows. So just simply keeping your pet cat inside. It's going to be better for your cat. It's not going to get eaten by a coyote or a great horned owl, and it's not going to eat these birds that are migrating through. Buying the right kind of coffee, believe it or not, can make a huge difference for migratory birds. Traditional shade coffee plantations in Central and South America are incredibly good habitat for the birds that migrate from North America down into the tropics for the winter. Unfortunately, what we're doing increasingly is bulldozing these traditional shade coffee plantations, which are basically just functioning rainforests with coffee planted in the understory. Bulldozing those and planting high-yield, sun-tolerant coffee, which produces the kind of inexpensive coffee that a lot of Americans like to buy. If you look for coffee that is certified as shade-grown, the Smithsonian Migratory Bird Center, for example, has a great bird-friendly coffee certification program. By buying that coffee, you're keeping small farmers in Central America in business and preserving hundreds of thousands of acres of incredibly important habitat for the migratory birds that are leaving your backyard in the fall and migrating down there for the winter. And, if you're a coffee drinker, you're going to drink coffee anyway. So by taking a little effort and looking for coffee that is certified as shade grown, you know that you're protecting and preserving, and in some cases actually even helping to restore bird habitat down on the wintering grounds where these birds spend the majority of their time. So it's, I know it can sound like kind of a depressing topic. We've hit on a whole bunch of depressing topics, depressing aspects of this today, but there's a lot we can do, and we can certainly turn this around if we put our minds to it.
The technology for studying birds has vastly improved over the last 20 years. Talk about the current technology and how it aids in the study of migration.
Oh, this is absolutely, you've hit the nail on the head there. I sometimes I find myself saying that this is a golden age for studying bird migration. I suspect that 100 years ago they thought it was a golden age for ornithology because we had smokeless powder and for our shotguns for shooting birds, and because that's the way we studied them back then. But it really is an amazing time right now. Like you say, technology, the miniaturization of technology is allowing us to track the migrations of birds that we were never able to track in real time before. I mean, we've had satellite transmitters that communicate with the Argos weather satellites overhead and allow us to track animals kind of on a moment-to-moment basis. We've had those for a long time, but they're big and they're heavy. About the smallest bird that you can put a satellite transmitter on weighs about 200 grams, like about the size of a small hawk. The vast majority of birds are much, much smaller than that. And, some of them, weigh less than half an ounce. If you put a satellite transmitter on them, they wouldn't migrate at all because they couldn't lift themselves off the ground. But now there are tiny little devices called geolocators that are data loggers that constantly record the level of daylight or darkness and allow you, once you've recaptured that bird the next year after it's gone off in its migration and come back to its breeding grounds, and you recapture it and take the geolocator off it, you can download the data and it gives you a rough latitude and longitude for where that bird's gone. So for example, the colleagues of mine that I'm working with up in Alaska, we've been putting geolocators on thrushes, on warblers, on sparrows, and it's the first time that we've been able to track many of these species of birds on their migration. There are tiny little radio transmitters now called nanotags that weigh a fraction of a gram, in some cases a fraction of a gram. Some of them are so small you can actually put them on butterflies and dragonflies to track their migration. And so, these new technologies are opening up windows on bird migration that we've never had before. And, again, showing us that these birds are capable of doing things that we never would have dreamt. For example, one of my former research technicians is working on his PhD right now, and he's studying golden-winged warblers in the southeastern United States. He's putting these little geolocators on golden-winged warblers and then recapturing them the next year and downloading the data. And one of the things that Gunnar and his colleagues discovered, to their shock, was a couple of years ago, this enormous line of storms with a tremendous outbreak of tornadoes was sweeping across the southeastern United States. And the geolocator data shows that these golden-winged warblers apparently detected these storms coming a day or two in advance, left their breeding range in Tennessee and Georgia, flew south hundreds of miles out of the path of the storms, waited till the storms came through, and then flew back to their breeding grounds again. Nobody had a clue that birds had that kind of sensory ability to probably, what they were probably picking up was both the drop in barometric pressure and also the extremely low frequency sound waves that are generated by enormous storms and wind and tornadoes. And that set off alarm bells for them, and they got out of the way of these storms, waited till the storms passed, and then came back again. So, this miniaturized technology is not just showing us where these birds are going, and that's obviously very important because it tells us what habitats we need to protect, what areas we need to protect and preserve and restore. But it's also giving us a window into the abilities that these birds had that we really just had no clue that they were capable of doing.
Changing subjects again, tell us about your work with owls, snowy owls, and northern saw-whet owls in particular.
Oh, I'm happy to talk about owls. So I've been working with northern saw-whet owls now here in Pennsylvania for, this will be our 22nd year of banding and radio tagging and doing a lot of other things with them. This is going to sound pretty obvious, but the difficult thing about studying owls is that they come out at night and they're nocturnal. If you want to study hawk migration, you can climb to the top of a mountain with a pair of binoculars and sit there during the day and count the hawks and the eagles and the falcons as they go by. That is not a recipe for success in studying owl migration. So what we do with the saw-whets is we study the migration by catching and banding them during their migration. We use mist nets, which, if you've never seen a mist net, it looks like your great-grandmother's hairnet, about 40 feet long and about 10 feet high. And we play an audio lure of the male saw-whet's advertisement call, basically his mating call, which doesn't sound much like an owl. It sounds like a garbage truck backing up. It's this mechanical, repetitive tooting sound. But we play that call. And the migrating owls, as they're coming south out of Canada, heading down through the lower 48, I guess they're curious. We're not really sure why they respond. It's not the breeding season. This is happening in the fall. But they come down to investigate. They get caught in the nets. We take them out. We weigh them and process them. We put a numbered leg band on them, let them go. The 3 stations that I operate here in Pennsylvania, with the help of about 100 volunteers, are part of a larger network called Project OwlNet, which at the moment is, I think we have about 125 cooperating banding stations across North America, from Canada down into Mexico, that are all using the same approach, using the same techniques. And so we're constantly trading banded owls back and forth with each other. So we've been able to connect the dots very, very effectively on where the migration routes for these birds are. When I started working with saw-whet owls here 20-some years ago, they were considered such a rare species that they were a candidate species on our state endangered and threatened species list. Most bird watchers go a lifetime without seeing a northern saw-whet owl. It turns out they're not actually rare. They're just rarely seen. Some years we've caught as many as 4,000 in a single migration season. But they're very secretive. They only come out at night. They're very difficult to find during the daytime. And So we're plugging ahead with that. We've used radio telemetry to figure out where do these birds go during the daytime, what kind of habitats do they use, how large an area are they using at night, what's their hunting behavior. I don't get a lot of sleep in the fall, but it's a lot of fun. And they're just an amazingly cute little bird as well. They're about the size of a soda can, big yellow eyes. Here in the east, they're the smallest owl we have. Out west, there's a number of species like elf owls and northern pygmy owls that are much smaller. But so that's one of the birds I work with. The other one, as you mentioned, is the snowy owl, and that's been another great example of how technology has allowed us to get a window into lives of birds that we've never had before. Now, the snowy owls, of course, are breeding up in the Arctic. They're coming south in the wintertime. And about every 4 years or so, we get a huge invasion of owls from the north, something called an eruption. And we started working with snowy owls 5 years ago during what was probably the biggest eruption of snowy owls in the Northeast in close to 100 years. There were thousands of them everywhere. And a number of colleagues of mine and I got together and said, basically, none of us are going to live long enough to see something like this again. And so, let's try to make the most of this opportunity. And so we started something that we call Project Snowstorm. And the idea of Project Snowstorm is to use these new high-tech GPS transmitters to study what these birds are doing when they're down here in the lower 48 with us. We actually, before we started this project, I think it's fair to say we probably knew more about the ecology of snowy owls on their breeding grounds in the Arctic than we did about what they're doing when they're down here, in the northern United States and southern Canada in the wintertime. So the transmitters that we're using on these owls, they're solar powered, and they use two technologies that most people carry around in their pockets every day. They communicate with the GPS satellite system overhead, so they're constantly recording highly accurate three-dimensional GPS, well, actually almost four-dimensional GPS locations. So they get latitude, longitude, altitude, and flight speed. And they can do that as often as every 6 seconds. And then at predetermined intervals, usually about once a day, they dial up through the GSM cell phone network and they send us the data through our cell phones. So, I get text messages from snowy owls, which I think is pretty cool. And it because we get so much information from these transmitters, it gives us incredibly detailed windows into the lives of these owls, which are doing things that we didn't know that they did. Or in other cases, it's allowed us to document behaviors that we suspected but had never really been able to study before. Like, for example, we've discovered that many of these young owls, when they come south on their first migration, will go out in the wintertime and spend weeks at a time out in the middle of the Great Lakes, out in the middle of the completely frozen Great Lakes, out in Lake Superior, Lake Erie, Lake Huron, miles and miles from shore, surrounded by nothing but ice for like 6 weeks at a time. And when we started seeing this, we thought, what on earth could they possibly be eating out there? But then when we started looking at satellite pictures of the ice cover on the Great Lakes, we realized that depending on where the wind is blowing from, there's big cracks and openings in the ice. There's open water out there in places like Lake Erie. It's 98.5% frozen during a cold winter, but that 1.5% that's not frozen, that open water is full of ducks and geese and grebes and loons and gulls and other water birds. And that's what these snowy owls are feeding on. That's the same kind of behavior that many of these snowy owls will follow as adults up in the Arctic, where they will winter along perennial openings in the ice called polynyas that never freeze up out in the Arctic pack ice. And in those polynyas in the wintertime are sea ducks like eiders and seabirds like murres and other alcids. So the adult owls are feeding on these seabirds on these openings in the ice in the Arctic. The young owls are doing the same thing on openings in the ice in the Great Lakes, which is something that nobody had any suspicion they were doing before we started doing this tracking. So it's been a really cool opportunity. And in fact, if any of your listeners want to follow what we're doing on Project Snowstorm, all they have to do is go to www.projectsnowstorm.org. And we've tagged more than 70 owls over the last 5 years, from North Dakota all the way up into southern Canada and New England. And all of the owls are on there. All of the tracking maps are on there. People can follow them kind of in real time as they're moving around. It's been a really, really cool project.
You've managed to write 24 books in your busy life so far, but I understand you're working on another one. Tell us about that.
Right. So the new book, it's as I said, it sort of functions in some ways as a sequel to Living on the Wind, and it's an examination of what we've learned about bird migration in the last 15 or 20 years. You know, the new science of migration and migration physiology, some of the kind of science fiction stuff that we were talking about earlier, but also looking at the state of migratory birds today globally. Living on the Wind focused just on the Western Hemisphere. The new book looks at bird migration worldwide. So some of the things that we talked about earlier, the Amur falcons in India, for example, the loss of coastal wetlands in the Yellow Sea in China, are some of the topics that I'm exploring with this book. I was down in the Bahamas with scientists from the Smithsonian 2 winters ago, helping them use these tiny little nanotag transmitters on federally endangered Kirtland's warblers to learn more about their migration. I'm going to be in the Mediterranean later this year with people who are working to try to stop the illegal killing of millions and millions of songbirds in places like Italy and France, where it's still a major problem. The Italians kill about 5.5 million songbirds a year to eat them. The French kill about 4.5 million, including some that are terribly endangered. It's a cultural tradition that is really causing a problem for migratory birds, but folks are trying to change things there. The new book is going to be called A World of Wings, and it will be out probably in the spring of 2020. It's going to be published by W.W. Norton. That's assuming I can get it done by the spring of next year, which is when my deadline is. That's what I'm shooting for. But it's been great. It's been fun to look at migration on a global scale rather than just in the Western Hemisphere, and also because there's been, as I said, so many new discoveries about what migratory birds are capable of and how they accomplish what they're doing. The physiology stuff is just kind of mind blowing.
Yeah, the size of the tracking devices these days and the amount of data they can hold and transmit's pretty amazing.
Yeah, sometimes a little too much, but it's been fun. And we talked before about the bad news stories, and just last week, as far as good news stories that tie into the first book, back in the late 1990s. We discovered that Swainson's hawks, which of course are one of the most common open country raptors across the West, from the Great Plains all the way up into the Pacific Northwest, these birds migrate down into Argentina. And in 1995, 1996, scientists discovered that tens of thousands of Swainson's hawks were dying in Argentina from pesticide poisoning. And so they worked with the Argentinian government. They worked with Argentine scientists. They had the chemical banned. They worked with farmers to convince them not to spray this chemical. It was an incredibly successful campaign, and I had an opportunity when I was working on Living on the Wind to spend part of one winter down in Argentina with the scientists working with Swainson's hawks. And the scientist that kind of kicked that whole thing off was a Forest Service biologist named Brian Woodbridge, who worked in Northern California, up close to the Oregon border, up in the Butte Valley of Northern California, studying the Swainson's hawks of the Butte Valley. Well, Brian now works for the Fish and Wildlife Service, and there are younger scientists that have taken over that study working in the Butte Valley. And I had an opportunity last week to go out there and spend a couple of days with them in the field, the population of Swainson's hawks in the Butte Valley that had been so decimated by that pesticide poisoning in the late 1990s has not just recovered, but actually is thriving today. The population has more than doubled in recent years. It's a real conservation success story out there, and so it was great to be able to spend some time with Brian and the other scientists that are still working on the project today, as they were climbing up into nest trees and taking chicks out and banding them and taking blood samples and getting all their vitals. And I know some of the adult birds whose chicks we were banding are probably some of the same birds that were the survivors 20 years ago down in Argentina, because they're a very long-lived bird. There's some that are 25, almost 30 years old in that population. Certainly some of the hawks we were working with were the kids and the grandkids of those birds that I knew down in Argentina. So that was a pretty cool thing, and a nice way to kind of bring the whole story full circle and back to a much more optimistic ending.
So where can people find you and all the things you're doing in your busy life?
Well, like every other single person on the planet, I guess, I've got a website, and it's just simply scottweidensaul.com. And there's a lot of information on there about some of the research projects I'm involved in, the snowy owl stuff, the saw-whet owl stuff, the work that we're doing in Alaska through the National Park Service, what we call our Critical Connections program. I'm also involved in studying western hummingbirds that are showing up in increasing numbers in the east in the wintertime, now wintering in the east. Incredibly tough birds that can actually make it through the winter in places like Pennsylvania, New York, and New England. So yeah, that's if folks want to follow me. I'm not on social media. I'm a bit of a Luddite that way, but they could follow what I'm up to on my website.
Well, Scott, it's been a pleasure having you on the Photographing the West podcast. Information about Scott, his books, his projects, and his research will be in the show notes. This podcast is published on the 15th and 30th of each month and is available on my website, www.flanaganphotos.com. Photos is spelled F-O-T-O-S, as well as on iTunes as Photographing the West and on most RSS feeds. Thanks for listening, and bye for now.
Thanks for listening to Photographing the West podcast. Please subscribe to the podcast in iTunes and leave us a review. Till next time, here's wishing you safe travels and good light.